Welcome. Glad everyone could join. We are in week 6. One more week, and next week we'll be concentrating on our project. So this is our last lecture. Enjoyed being with you all, and hopefully that you got a better understanding so far, okay, of what we've been doing as far as operating systems. We've talked about processes, we've talked about memory, we've talked about hardware devices, and we talked about files and file structures. Today, we're going to end up the discussion on operating system security, protection, and virtualization. Okay. The key topics that we're going to be working with here, and let me go ahead and hit this one more time. Okay, what we're going to be concentrating on here is, looking at a different kind of point of view of the operating system fundamentals. Looking at authentication and authorization, a key portion of the operating system control. The access control models. Okay, what are the ways that the types of ways that we can control the access? Protection and memory security. Very important. I have something in memory. I want to make sure that no one else can get to it, basically. Okay. So looking at protection and memory security, encryption and data protection. Another way of protecting data through encryption. We'll be talking a bit about that. Malware and protection, of course, that's one of the key things that we have to talk about as far as the operating system and how it prevents malware from basically getting to secured information. Virtualization concepts and technology, hypervisors and virtual machines. We talked about virtual memory, okay, but of course we can extend that from just memory to the entire CPU, the entire computer. So we can, in essence, have an operating system that has virtual machines or virtual operating systems. We can get that. So we'll talk a little bit about that, just kind of get the concept down on what we're doing there. And then security and virtualized environments, since we're talking about these virtual machines and virtual memory, how does that change the security of what do I have to protect, and how do I protect it when it's virtual and not really, let's call it real. Okay, so let's go ahead and get started. Operating system fundamentals, resource manager, that's what basically we've talked about the operating system being. Service provider provides various services, control program, abstract layer, hides hardware complexity from the user. That's the purpose of the operating system. The key points: operating systems acts as intermediary between users and applications. Bottom line, okay, that's our purpose. All this we've been talking about has been, what does that intermediary do? Supports multitasking, scheduling, memory management, file management, device management. Okay, all the things we've gone over. Modern operating systems are designed for performance, reliability, and security. Okay, authentication, authorization. These are concepts you may have already touched as far as through your programming journey, but authentication, who are you? Okay, verifies the identity of users and processes. That's the purpose of authentication. Versus authorization. Authorization says, what can you do? So once we know that you are who you say you are, then based on that, what are the functions that you're allowed to do? So grants or denies access to resources based on who you are, determines permissions, files, directories, and devices, which ones can you get to, and based on roles, groups, or individuals. So I can, put yourself in a group and everybody in the group can have this authority, or I can do that individually from person to person. Access control models. There are various access control models. Access control models define rules and structures for determining how subjects, users, and process can access objects. Okay. Okay, so determine that different types of access control models. Here we're talking about discretionary access control. Resource owner decides who can get access. Mandatory access control. System enforces access based on security labels. Role access control based on the role that you've been assigned to that determines your access. Attribute access control. Access based on attributes of the user, the resources, the environment. So based on what you look like or what your purpose is, we're going to take those attributes of who you say you are and use that as a basis for access control. And then capability based access control granted through capabilities. Another term for that is tokens that users possess. Users can pass capabilities to others. In that sense, giving basically a sub authorization. So you're allowed to do this, and we're going to determine whether you can take that and give that to someone else. Okay. Okay, protection and memory security. Protection ensures that users and process cannot interfere with each other or the operating system. Protection mechanism, our user can be in user mode, kernel mode. We talked about, when you're in user mode, when you're in kernel mode. CPU has at least two modes. Kernel mode has full access. User mode is restricted. System calls. Users request services via controlled interfaces. Permission checks. Operating system checks permissions before allowing access to files and devices. Again, we're now talking about protection and memory security. Memory security techniques that are used by various operating systems. Base and limited registers, define legal memory range. You can get anything from this start of this memory point to this memory point. That's all you can get to. Okay, so that's memory protection keys, address space layout randomization. Okay, randomizes memory addresses to make exploits harder. Okay. So not have say for example, have a contiguous piece of memory that contains information, but maybe randomly placing those in different places. So everyone or someone who can get in or may get in doesn't have a direct path to the information that they might be looking for. Data execution prevention prevents execution of code in data regions. Okay. Then we have encryption and data protection. Okay, encryption again transforms plain text into ciphertext using algorithms and keys. Keys are systemic or asymmetric. So symmetric or asymmetric. Those are keys. Asymmetric. Okay, we'll talk about that kind of later on in the discussion. Data in transit, use protocols, TSL, SSL to protect data. Okay. Look it up. Yep. Yeah, here's our old saying. Okay, look at what are we talking about? TSL, SSL. Okay. Take a look at it. Data at rest, encryption files, databases, storage. And this is versus data in motion. Mm-hmm. Okay, so symmetric encryption, same key. Okay, let's see who was looking ahead. Okay, symmetric encryption, same key for encryption and decryption. Okay. If I have the key, I can send something and encrypt it, and I can receive something and decrypt it. Asymmetric, okay, is saying that I have one key that does encryption, another key that does decryption. There is a whole course, okay, on how that information is controlled and passed from one person to another person, as far as whether you're doing asymmetric or symmetric. Cryptography, okay, take that course if you haven't, sign up for it, okay. But it talks about encryption and data protection. Okay, malware. I mean, that is something we definitely have to worry about as far as operating systems. Malware is malicious software designed to disrupt, damage, or gain unauthorized access to your system. The operating system provides multi-layers of defense to detect and prevent this from happening. But the types of malware, we have viruses, we have worms, we have Trojan horses, we have ransomware, we have spyware or adware. Okay. These are the type of things that we have to kind of protect our have the operating system protect us from. Okay. Malware protection techniques, how do we do that? Antivirus, anti-malware, behavior analysis, monitors program behavior to identify, whether it's acting weird. Okay. Firewalls, blocks unauthorized network connections, regular updates and patching. And, you'll get that notification that, hey, it's time to update your operating system. We'll do it at night, or you can do it right now. So those kind of messages. User awareness and least privileges educates user and limits permission to reduce infection risk. Okay, virtualization concepts. Okay, we talked about virtual memory here. We're kind of jumping into the big time and talking about other virtual techniques. Abstraction hides physical hardware details from and presents visualization resources. Now, isolation, each virtual environment runs independently. So this is just kind of highlight here. And, I can have a virtual environment, just one, or I can have multiple virtual environments and keep control of each one individually. So that's kind of the isolation part discovered here, that with the various isolation environments I set up, okay, I need to be able to isolate them so that they cannot be overlapping and basically interfering with a particular virtualization environment. Resource pooling, CPU, memory, storage, network resources are shared, okay, through these various virtual environments. Partitioning, physical resources are divided among multiple virtual environments. I can actually divide memory based on, or partition memory based on giving each virtual environment their own piece of physical memory. Okay. So I can do that with partitioning. And then encapsulation, virtual machines and resources are packaged as files or templates. There's in a section, I'll take everything that's needed for this virtualization, I'll put it in a package. Okay. And basically that's the information and encapsulation of all those capabilities that is needed by that environment. That is coupled together and said, here, virtualization 1, here's your stuff. Virtualization 2, here's your stuff. So that's what we're really talking about there. Okay, so better resource utilization, cost savings, scalability, all these are key things. High availability, easy backup and recovery, concepts and technology for virtualization. Then we have this concept called hypervisors. A hypervisor creates and manages a virtual machine by allocating hardware resources and enforcing isolation between them. This is basically probably what you think about as the ultimate step. Okay, this is where I'm taking an entire machine and basically virtualizing all of their functionality. So everything we've talked about right now for this course, think of it that we're taking this information, everything that we've talked about, and we're putting them in virtual machines. Okay. So virtual machines says I have one physical machine, but I can basically copy and create virtual machines from those. Okay. Hypervisor keeps track of that, keeps track of the connection between the virtual machine and the physical devices that are needed in order to do what the virtual machine wants to do. So that's basically shown here, that as we have multiple virtual machines, the hypervisor does that control that enables everybody to get the resources that they need based on their particular machine. Security and virtualized environments, very important. We talk about hypervisor security that controls all these virtual machines we've just created. And, and virtual machines is very common. It's not really anything new. It's been around for a while. There's some drawbacks with virtual machines, but it basically definitely a cost saver in that I don't have to buy another computer. I'll take what I have and I'll create a virtual machine or two virtual machines out of it. Okay. Okay, so hypersecurity, virtual management isolation, virtual network, okay, best practices, regular patching of hypervisors and VMs, use strong authentication or multifaceted authorization. Okay, so these are the things, just things that we've already talked about, but now that we're talking about a virtualized environment, you know, how do I take everything that I've talked about and basically secure these virtual memories or virtual machines so that they don't interfere with each other? Security in virtualized environments. Okay, well that's it, folks. That's week 6. Again, look over this. Be prepared for your quiz. Um, yeah, even though yeah, we'll go with that. Okay, so you'll beware on Tuesday. Be prepared. Take your quiz. I will be releasing the project for week 7. Okay, so you should have already seen that and be prepared. If you have any questions, follow up for Tuesday. Been a joy. We'll be seeing each other uh, hopefully one last time come Tuesday. So thank you, everyone, and have a good study, and we'll see you later. Have a good one. Bye.